There you go. Okay.
Yeah, after you're done with the meeting, it'll pop up with like all your recorded meetings, and then you can download them and
So
throw them back up on.
It's gonna it's recording in the cloud, right? So I'm not gonna worry about running out of space or anything, right? I hope.
Correct, but you actually do have to download it. You can't directly reference the cloud file.
That's actually better. All right, so so that's good. If I can minimize this. Okay, can everybody see my screen, right?
Yep.
Okay, so I created a new repo for this, and the code is I just creatively called it source, and I checked everything in here. So these are the common libraries for the to enable the caching solution. And let me see. So let me start just with unit. Okay, that's the first thing. So the idea of this is to provide a caching solution which is flexible, and then we can swap out the cache provider, depending on where we are. Let's follow out with a picture. Let's start with this. So for this thing to be successful, we should be able to deploy, caches anywhere, anywhere here, right? So let's say this is HTTP, so that let's say this layer here includes client caches, proxies, gateways, client, public, private caches in the browser, something that we really don't have much control of. And then this is our world here. So we can cache. If our stuff is running in Azure, there has to be a way to cache there. Or if we're running, on the internal network, we should be able to cache. And depending on, depending on breadth, cost of caching, cost, speed, different caching solutions apply. For example, you can do in-memory caching versus out of process caching versus distributed. Does it make sense so far? I see you guys nodding, so I guess that's a yes. Going forward, some of these caches vary from cost to performance hit to the effectiveness. For example, and the closer you are to the process, obviously the better off you are. So for example, in-memory cache, RAM, that's the fastest you get. But the problem is if your app pool recycles or the process dies, you lose that cache, right? Versus if you have an out-of-process cache but still runs on the same server, you're a little bit more durable, a little bit slower because you have to connect to that process, but it's still on the same server. Versus distributed, where now you are not on the same server, you have some kind of cluster that you need to connect to, versus disk cache, for example, or something that is much more durable but much slower. And the idea is that with the solution, we should be able to deploy this, and if something doesn't work, we should be able to scale this, change the cache type on the fly without recompilation and redeployment. Does that make sense?
Mm-hmm.
All right. So how do we do this? Going back to, I'm going to show the with a unit test. So let's say you have some kind of repository, or it could be anything, that has a method that searches the database. You pass it a code, it goes to the database and it returns. So all you have to do to make caching available is just to put this little attribute here. Obviously, you gotta add a reference to it. Right now, because I'm gonna step through the code and I want to show the steps, I I added references locally. But then this can be all NuGet packages coming from our server. But because I want to step through, I added everything locally. So by just adding, so this is the minimum, right? The minimum for the cache to work is this cache attribute, and then the NuGet DLL library, and config file. Bare minimum for the config file is this. So let's run with a bare minimum. That's all you need. Okay, so all you need is just add a custom configuration section that that we added for this, and just say I want to use caching, and it's gonna default. It has its it has defaults and defaults out to memory. And let's demonstrate this. So what I'm doing here in this test, right? I am injecting, basically, I'm getting an instance of this mock repository, right? And then I'm calling the same method twice, right? I'm calling it the first time, and with the same parameters, it's the same method, right? The first time you call it, there's no cache. It's not in the cache, so this will take, this will go here. It will, it will take 3 seconds, and then it will basically return. But the second time you call it, because you added this cache on it, it should be already cached, and it should not take this. It should not even go here. It should basically return right away with the cache stuff. Does that make sense? So let's run it. So this guy right here is going to take a performance hit. So as you can see, it's navigating into this method, but by this point, it should have already cached it. So as you can see, it returned, and it found one car that matched. Now I'm going to call this method again, and this guy better not, see, it did not go back to this method. It never hit this because it already cached it. And so this result is the same, and it returned. So now I can actually run a mock doing the same thing more than once. So basically, at this point, I'm going to actually mock out the cache, and I'm going to simulate calling search 3 times. And then I can assert that the first time the cache, the get method gets called only once, and then the set method gets called only once. That's when you set the cache. And then every time after that, when you search for the same thing, you get method gets called twice by this point, because you called it once here and once here. You search twice, but the set, it still got called once, because you're not setting the cache the second time, it's already in cache. And then next time you try to search again, your get only but this time it got called 3 times, but cache set was still only called once. And let's run this guy. Okay, so it passed. Now to you guys, that doesn't mean much at this point. Now let's start playing with this. So now, let's say at this point by default, it's using memory cache. So instead of memory cache, I want to switch it to a different cache type. So I'll show you right now. The cache types that we have available are null cache, which is no cache at all, memory, and then these are distributed caches: Ncache, Redis, Azure Table, Storage, or Disk. So for the demo purposes, I will show you the disk one, because then you can actually see what's being cached. So let's do this. Let us, so by default, okay, so now you decided, okay, I want to swap out cache. 2 places you can do it. Either you can provide it right here on this attribute. So let's do it now. And I want to switch it to disk. Okay, and then you have to configure in the config file. You say for my disk cache. Usually the way this works is that you have to have a shared place, like right now I have a folder here on my hard drive that I'm sharing, and that's where the disk cache is going to be used. And the reason why you need the disk cache in the first place is if we're building a CMS, it's a common implementation, you know, where you can you have gigs and gigs of space where you can actually cache raw HTML response for some of your widgets, you know, part of your CMS mechanism. That's where, you know, we use this you know, disk cache. So let's do this. So all I changed was I configured disk cache here to go to my local cache folder, which is here. There's nothing there, and I'm going to run through the same tests. You know, I'm still on my repository. I did not change. You know, all I did is I configured this method to use disk cache, and let us run this test again. So remember, the first time it goes here, it goes to that method, takes the performance hit of 3 seconds. The second time, it doesn't. Run. Okay. So as you can see, here's your thing that was cached on disk. And it's right now encryption is enabled. So let us go ahead and disable encryption. So we can see what actually gets cached. And that should be as simple as flip off encryption here and run this again. And you can see the object that got cached serialized here. Now, let's say I leave it here and I run this unit test again. Because this is considered like an out-of-process cache, disk cache is more like even distributed cache. When I run this unit test again, it should not even cache the first time because cache is already there. So let's test that. I don't think I tested this scenario. So if I try to step through this method, it should return right away. Yep, it never went through. So it never hit that performance hit of 3 seconds. And the same thing here comes right back because it's pulling it from cache. And let's flip this. Let's keep it off. Now, the question is, what if you already deploy this out and disk cache, and you configure it. Let's go back. You want to configure this guy as back to default. Let's like this. So it defaults out to in-process memory, and you configure this out, and you know, we'll talk about measuring performance, and performance sucks. I mean, it's basically the cache type that you picked. Either it's always, you know, you have a lot of misses, you just didn't plan it, or something that you thought like was static, but it turned out to be dynamic. This happens a lot, you know, and you want to configure, switch it to a different type just for that one method. You don't want to, you know, you don't want to redeploy the solution. You just want to change it for one method. The way you do that is by, again, using these. Now you can use these targets, and you say that you configure, and I'll talk about prefixes, but basically you say this method, I wanted to use disk. So right now it's configured to use memory, and let's be specific about it. This method right here, right now, is configured to use memory, and it's deployed out like this. But then in my config file, I say, no, this method is it needs to be using disk. And that should override it. So you should see, when I run this, you should see it here, because it's gonna default, it's gonna override it and use disk. And as you see right here, it took it and it overrode and it used disk. Now, again, you know, I'm just using this as a demonstration. It could be, it doesn't have to be disk. It could be any one of those, you know, you can switch it to any one of those cache types that are available. Let me just show you again the ones that are available. And then we can add, we can plug in more, right? Right now, the ones that I implemented were just these, you know, the most common ones. Redis, Azure Disk. Yeah, this is the one that we're going to roll out with, is the N cache. That basically, I'll talk about this in a second. So that's pretty much it. So right now, once we have this installed, we can get the performance gain right away. But you guys just going in, and all our in our source code, we add this as a NuGet dependency, and then you just add this one line of code and one and two lines in the config file, and then we have caching enabled. Let me pause here, and you know, please ask questions.
I have a question. So how is this set up for like user-specific caching?
You talk, which part of this diagram are you talking about?
Well, I'm client A, right, and I have my own set of data that's cached, and then client B has its own set of data cached.
Not necessarily by client, it goes by the key. So it's
Okay.
We're using the same methodology as client caching, you know, like the HTTP 1.1 standard. You know how they're using verb, method, vary, headers. So when I talk about how I implemented this, you'll see how we're generating the key. So by the key is basically generated by the name of the method, and parameters. You see how it's naming it? Mock repo, search.
Yep. Yep.
And then whatever the parameters are passed, they're being hashed.
Okay.
So next time somebody else, client A or client B or client C, next time they call the same method, it will use the cache. It will hash into the same, you know, hash key, and it will get the same value back. Just the same way it works right here in the HTTP caching on the, you know, on public gateways, or on reverse gate, like on Squid, whatever. That's how they're doing caching. So I did the same thing there.
Okay.
Anybody else? Now, is anybody curious to see how this works? You want me to talk about this?
Sure.
So let's look at this. So, okay, so what is happening? What should happen with any kind of caching solution, right? What you should do is 3 steps is always, right? You generate the hash key, then you need to check if you have that item is in there, in your cache. If it's not in there, it's a miss. So you, register, log it as a miss, or you send a performance counter, set a performance counter as a miss, and you add it to cache, and then you return. And the next time you call it, you get the cache key. You check, oh, it's in there now. Then just read it from there. I mean, these are the steps, and these are the steps that are repetitive. Every method. Let's say, for example, if we wanted to do it the old way, on the repository, this is what you would have to do here, right? Not necessarily on the repository. It will be a little bit higher up the chain. It would be on the manager or something that would call the repository, return the data, and it will do these steps. It will create the key. It will check if it's there. If it's not there, add it there. Then go to the repository. These are the steps. Good with everybody? Yes?
Mm-hmm.
Now, that's what this guy is doing. This one little tiny attribute over there, it's doing all of that for you. And it's using, we're using AOP, aspect-oriented programming, to do that. So let's look at this attribute. And this attribute is, that's where the magic is. So we're using Unity interception for this. So what's happening is that Unity container will intercept the call, and it will reroute the call to your, it will reroute the call to your method. So you have the method here. By putting this cache attribute, or it doesn't I mean, this is our custom attribute, but any attribute, Unity interception or any kind of container interception works like basically you specify how are you going to handle the your aspect. In our case, the aspect is caching. But usually other aspects examples deals with cross-cutting concerns like logging, error handling. Is anybody familiar with AOP programming? Anybody? Okay. So it might seem a little bit like a black magic, but it actually it reduces the size of the repetitive code, and in terms of bringing new developers, you just tell them you want to make it, you want to intercept this method, make it virtual, and add this cache. That's all you have to do. Because what's really happening is that when you the bottom line is the way this works is that in my unit code, in my unit test, I'm asking this container to give me, usually you would be asking for the interface. So, you have a repository or whatever the class is, and then you have an interface that thing is implementing. And usually you ask the dependency injection container or inversion of control container to say, give me an instance of that interface. In this case, I'm kind of short-circuited, but that's what's happening. Now, what this guy is going to do is going to say, do I have interception enabled? And I do. So what it's going to do is it's going to create a named proxy, which is going to basically inherit from this repository, and is going to override anything virtual that I have. Do I have anything virtual? Oh yes, I have this virtual. So it's going to override this method dynamically. So this is not, this is different. This is interception on the code container, which is different from ill weaving. So another technique to inject your code would be to inject into the actual ill code that gets generated after the compilation. That's called ill weaving. We are not using that, but so I'm not going to talk about it. But basically, so the container is doing all the trick. So this container will give you an instance of this repository, actually a proxy for this instance. And just to show you that I'm not lying, so normally you would expect after this result, you would get a mock repo class, but not quick, because see what's happening? The actual instance is dynamic module wrapped mock repo and some hashed value. So you can see that at action, your inversion of control container created this dynamic class. It included the code for mock repo. Basically, it inherited from mock repo, and it overridden whatever this method, and it brought all the logic that's inside of this attribute. That's it. And the way you do this is by so now I'm going to go back to the structure of the code. So I have added, and this is kind of I'm rolling this out, and it's a good thing to follow. Basically, this is part of our common framework or core framework. So we have common caching, then different kind of providers, configuration. We see a lot of I see a lot of configurations that are just kind of stuck in a collection, config collection. We're gonna use custom configuration, so we can configure, so we can actually do this kind of thing. So this custom configuration is what allows us to do this custom config section and configure the targets and all that stuff. That's in, this code is in here. Now the container, I prefer Unity, but there's Ninject, Castle, it's all swappable, doesn't matter. So we're gonna use Unity. And basically here is where we're configuring the interface. This is boilerplate code. Actually on the caching. This is where I set up, usually this is where I set up, say, you know what, I want to register anything that's basically iCache. So we have a cache factory. I'll get to that. And the serializer, the same thing here. Let's see. And I'm adding the interception. Basically, that's the Unity interception that's going to react to the intercepting of anything that's virtual. And let me go back to base. Right here. So that's the magic. So this, whenever you configure your interceptor, you telling this anything you see that's marked as virtual method, you're going to override that in your dynamic proxy, and you're going to inject the logic from the aspect as a part of the aspect-oriented programming. So basically, the way this works is that when you run this, when you put that little tiny cache decorator here, right? This basically hooks everything up, and it says this cache attribute is actually you see the Unity interception, so it's part of this whole interception mechanism. But basically, this cache call handler. So what that means is that anytime that method gets called, right? Anytime it gets called, this guy is gonna fire, and it's gonna do some business logic before and after that method is called, and that's where I'm doing all my caching. So as you can see, proceed basically says run the method. So as the flow is going, as the logic comes in, it tries to call this method. So unit test tries to call search, but the interceptor will intercept it and reroute it to this handler. The handler is going to do some stuff. Then it decides now it's the time to call the method. The method will run, so it'll come back. The flow will come, and I'll step through this. And then after it returns, you see method returns. Then you can do stuff with it. So basically, you can cache it, and then and then you know, kick out. That's all. That's pretty much all we're doing, and a little bit of reflection, and that's what allows you with one line of code and some configuration to dynamically configure all our search methods. You know, anything you want to be configured. And you know, I want to deploy this, you know, fairly soon, so we can actually, you know, enable this on our current solution and see this in action. So before I step through it, any questions? It's got to be questions. All right, so no questions. So let me step through. And I'll put a breakpoint in this handler. Let's switch it back to memory. Let's get rid of the override. And let me run this. So I run this. First time, it will go to that interceptor. It will generate the hash key. It will check the hash. It's not going to be in there. It's going to call the method. Method is going to return. It's going to take the return. It's going to serialize it. It's going to put that in cache. It's going to kick out. Second time I run this, it's going to get intercepted. It's going to generate the key. The key is going to match. It's going to check the cache. The entry is going to be there. It's going to just return, and the method never going to get called. Does that sound reasonable? At least this is what I expected to happen. So let us debug. So I am going to step through. So I'm F11 into this guy, and you can see interceptor call. It intercepted. So it has not gotten to the repo. It did not come here yet. Right now it's inside of here, inside of this thing, and that's where it's gonna use our. That's how this configuration comes into place. So it's using the config thing that we have, and it's checking basically. You can turn off cache globally. So that's the statement here. Enable caching equal to true. So you can have this very complex solution, and it's basically, you know, for some reason you have many caches and all this, and it's something is going wrong where caches just slowing down. So you basically with one switch you can turn all caching off. No change, no code change. In this case, the caching is enabled. So in this case, if caching is not enabled, it's just gonna like go back to regular execution and return. Now here is Justin, your question. It's going, oh no, here it's basically, it gets the, reflectively, it's getting the value of this cache attribute. So what that means is that this attribute, it can have many configuration values. So that's what that is doing. It's getting the values reflectively. It's getting the values that were configured. You know, all defaults. You know, what kind of type it is, and you know, lifespan of the cache, serialization format, all this. And then at this point, on the cache attribute, you can also disable it. So each method can selectively disable cache for a particular method in code. Okay, here is where we're going to get a factory, and we're going to stamp out an instance of the iCache that we're requiring. Here by default is memory, but let's step into this cache factory, and this guy is basically, it's going to stamp out whatever cache you're referring to. They're all basically going to get the instance of that, and it's going to get initialized. So basically that's object oriented. You know, you're going to have iFactory, or you have iCache, then you have an abstract cache class, and then you have all the polymorphically all the other caches which basically implement that interface and inherit from that base class. And then so here, Cache Factory can stamp out the correct cache implementation if you have it registered. If not, it's going to kick out. In this case, we're using the actual provider for our cache is Memory Cache, which is a .NET. That's like like Web Cache used to be. It's system.runtime.caching. And then the same thing, Serializer Factory is going to stamp out JSON serializer or XML or binary, doesn't matter. So now we're all ready to create. Okay, so we're also instrumenting cache requests. So if we have any performance counters enabled, we're not, but we can see our cache hits, cache misses, and so forth. Figuring out return type here. So this is how we're going to generate the cache key. So the cache key is built on the prefix, which is really the method name, class and the method name. Yep. And key, we get hash it, and if there are any parameters, you would get that. So now cache key is that. That's what's going to be used as a cache. And cache value is, it actually goes to the cache, whatever the cache is being used, and it gets it. It hits it and gets the key. In this case, there was nothing there, so it's going to go to the database. It's basically going to run your instrumentation. It's going to call the method. See, now the method gets executed. You take the performance hit of 3 seconds. Method return. Now we're back in the aspect. And we're going to take the value that the method returned, which is this model, the object. It could be anything. And it's going to serialize it using our default serializer if we're setting lifespan. And it's going to set it. And it's going to kick out. Done. Boom. Go here again. Same, it got intercepted. Now things should be a little bit different because now that object is in memory. So cache value right here, you better have a cache value, and you do. So it's not, no. So it's going to say, okay, it's a hit. And it's going to deserialize it. There's some reflection here. And you're out. And you cached, and you're done. And I think I'm done. I'm not even going to worry about talking about the performance counters. We have them. It's part of the Perfmon, part of this guy. So we instrument the hits, the misses, but that's boilerplate stuff. So that's it for me.
Okay, cool.
Very cool.
So in terms of, if you have any questions, in terms of us using it, once I get the NuGet built, and it's going to be building continuously, right? So you just roll in this my tasket caching, right? You just add this section, you add the caching enable true, and then whatever methods that you want it to be cached, you just mark it with cache, right? And then we can play around with the cache store. Even if it's an in-memory cache, you will still get a performance because the app pool is going to be hosting that, right? So just out of the gate, without any distributed, without any server set up, we should be able to deploy this out and speed things up, tremendously. But the two ones that I'm thinking about, once we deploy this out, the stores are really, in memory is not really it's super fast, but it's not, it's limited on terms of how much RAM, how much you can store in there. The ones especially for this task that I have for the opcodes, we're going to be using out of process cache, which is Ncache. So Ncache, it's like N service bus, Ncache. It's this open source solution. It's like it runs. It's a Windows service basically. It's a Windows service that running on that it's going to be running on our server, and it's going to be managed. It's going to be storing stuff in RAM, and but it's not dependent on the if the app pool recycles, you still have that stuff.
I have a question.
Yes.
Since you mentioned the opcodes, how are you going to refresh the cache? We do know that it's in the most case scenarios, it's the same, but from time to time, new opcodes are added, and they added by different opcodes, added by different clients.
Right. So that's a great question. So I think this is a tangential concern. So once you get into cache, refreshing the cache and keeping it fresh, that's a common to everything, right? Make sure it's fresh and whatnot. So I plan for this one, I plan to first establish a lifespan for this guy, let's say a day, maybe. After a day, it will just basically gets destroyed. And we're going to cache all opcodes per client, right? Because one of the methods that are passed, that it's going to be client ID, right? So it's going to get rolled into the key, and we're going to have an external process. I think that's how Chad wanted it. That is going to basically run and invalidate the cache and repopulate the cache outside of this.
Okay. Yeah, I like the idea because opcodes are different per client. Although, just keep in mind the scale of it. We may have 1,000 clients. We already have 1,000.
Right. So that's why we tried, and that's why we have different caches that we can try, right? In the worst case, is disk cache. No matter what kind of scale, going to disk is still faster than going to SQL running a stored procedure. You see what I'm saying? So I completely, that's why I wanted to put in the time and make it so flexible that we'll try Encache, we'll try disk, we'll try Azure tables, and we'll try different things until, if we see that the value, because, I built in performance counters so we can see the volume, you see the, we can see the misses, the hits, and all that. But the key, we don't have to worry about creating the key because the framework does it, right? It creates by the method, by the parameter. Right. As long as you think about, whenever you write your method, you already think about, okay, what parameters do I need to pass to differentiate different clients, and then the returns. Once you do that, you already have a cache key, right? And then now, how long it's going to live, how much memory that's going to take, because of the flexibility of the framework, that's up to the developer. And it's I'm not saying it's easy, right? It's still kind of like an art. So what we have to do is always think about, cache being out of, being stale and what is the lifespan. But, as part of the sprint, the deliverable will be this framework, and the method that I'm writing is going to put it in there for a day, I believe, but it's going to be flexible. And then I have another console application that's going to run daily, and it's going to basically kill everything and reload it. And then we can configure if it doesn't need to be running every day, like you're saying, if it's, but probably I think we better be less efficient but more accurate,
Would that be possible to link it to DocMaster, so when they add an opcode, it automatically calls our method to refresh the cache?
Absolutely. Again, this is a different tangential concern, right? That's part of the change tracking and
right. Next, I understand.
Yeah, that's the next piece of puzzle. This one really just isolates the actual caching methodology. And caching is an aspect, part of the AOP, and giving you guys the flexibility of you say, I just want to cache. I don't care how you do it. I want to cache, and I want to control after the deployment. I want to control. Okay, well, some methods are not as efficient. As you can see, you can have this repository, right? That can have tons and tons of methods. Like this is basically this mock repository. It's our data access, our DAO, right? That has tons of methods. So we're going to start decorating some of them, or most of them, with this cache attribute. And then some of them are more expensive than others. So some of them can be routed to memory. Some of them could be routed to Encache. Some of them could be going to Redis, which is super fast, distributed, but very, very expensive, you know? So, you know, depending on what we're caching, we can play with it, and then we can monitor our performance via the performance counters and see that some of them, you know, never change. Well, some of them, you know, we need to bust the cache and basically invalidate it via this process, but it's a different, you know, different step. That's all. At some point, it's also on my list, but you know, another quick question kind of related to this is where is this going to be running? And for now, it could run anywhere, but for now, I am proposing where, you know, our production web server, we're going to install the Ncache service there and give you guys, well, some of, you know, if you're running it in memory, that does not depend on the solution. But if you're running it, if you want to out of process caching, you need to have a server, which is Ncache. Great questions, Alex. Any more questions?
No, I'll watch the video. Sorry. I just got off my other meeting, but
Oh, I'm sorry.
just a real, oh, no worries. Just a real quick question on setting this up. I see the attribute cache. Is that keyed off of the string that's being passed in for that method? Is that kind of how the attribute works? It just looks at the incoming param and that's the key, or?
Yes, I kind of talked about it, but yes. So basically, if you look at the interceptor, it's generating the key off of so
Okay, just the
yeah. Let me just
cache factory.
let me step one more time. So let me see. So basically, just kind of quick recap. I think it's good for everybody. So you know, you want to use the cache. You include. It's good. We'll just run real quick. You want to use the cache. You include. It's going to be a NuGet package right now because I'm stepping through. I reference some locally, but if each one of these guys will be part of our NuGet feed. This is something new, but it's really, really good for us. So we can start breaking stuff out. And so I added a plugin here. It's called Packages. And these packages, that's basically our NuGet server. And these are like the swim lanes. They're feeds. So these feeds will live in this common, you know, basically, you know, I'm gonna once we're done with this, I'm gonna hook everything up. It's gonna be building continuously packaged up with a new version. And then, you know, next time you load the solution, it says, oh, there's a new version you want to update. We're using NuGet feed through that. And then you basically connect to this feed. But right now, everything is connected locally. So all you need to do is add your common caching. And then if you're using anything more specific than disk cache, memory cache, you know, if you're using like Redis or Azure Tables that needs its own DLLs, you're going to have to roll in something else. And then you just, on your method, you make it virtual and you mark it with this cache attribute, and then you add app config file, custom section, and then you're done. And so let me show you. So you step through this. So notice I'm calling this method 2 times. The first time it's using by default in-memory cache. So the first time it's not going to be in the cache. Second time it should be in the cache. So the first time it's going to go to this method that's marked as cacheable. It's going to take this performance hit. Next time it's not going to take the performance hit. So let us run through. So I am about to step in F11 into this method, but the interceptor fires. So the interceptor intercepts the call, gets the config stuff. Cache factory is the one, as I said, it's going to basically give you the cache that you're asking for. If it's an in-memory, whatever, it's going to provide you that cache backing. Serializer, same thing. Right here, cache key. So the way we're doing cache key is like you're saying, exactly like you're saying, you get the prefix, which is the method name, and then the parameters gets hashed out. So every time, let's say if it has to do with like opcodes, for example, then it's going to be per, Alex was asking this question. So it's going to be the name of the class, the method, and then the parameters. So if it's client 1, you know, give me all hash codes for client 1, that's going to be the key, and those hash, you know, returns will be hashed.
And is there any limit or to the type of incoming parameters?
Absolutely. It's all, as you can see, it's all generic. I'm using, you know, reflection, so we're reflectively looping through all the parameters, and it could be, you know, there's no limit.
Okay.
Right here is a cache miss, so we instrument cache miss. We call the methods. Method goes in there, goes to the database, takes the performance hit, 3 seconds, returns. Interceptor, basically, this now you have the return method. Now you can basically serialize this, which is return value is the actual class, but it could be, these are opcodes, for example. It's going to set the lifespan if you have it. We don't, and it sets it in cache. Now, remember, this cache is iCache. Right now, it got the factory produced memory cache because that's what I had it configured. But you can dynamically, or with a config file, you can swap out. You know, if you don't want to use memory cache, you want to use Ncache or Redis cache. It's all configurable, right? So now it sets it in cache.
That would be by class, right?
It could be. It's actually much more configurable. It could be by class. It could be with code. It could. It could be from a.
Never mind. I saw that method below where you were actually specifying the type.
Right. So it could be by method, right? It could be by class, or it could be by config file. Right here, you say, I want this particular one. After this has been deployed, I want to switch it to this. Yep. And so now, now I'm about to call. Look, I'm about to call the same search, the same parameters. I'm about to call it the second time. So the interceptor kicked in. It's gonna hash out. It's gonna get the same key, right? We know this. Now it's gonna go to cache, and now, we have a cache value right there. We don't have to set it. We'll just instrument that's a hit, and some reflection here, and it's going to return it, and boom, you're out. You never went inside of this method. You never took that database performance hit, and you're
awesome.
And as I was saying, for the developer to use this framework, you just need to make sure it's virtual. And then, chat, you can watch the video for more details. They just make this method whatever they want. They just have to make it virtual, and they just they just say, okay, I wanted to cache it, and then by default, memory, again, it's an in process, is the best one you can get. It's the quickest one, but it's gonna die after the app pool recycles, because it's in memory of that process. So the next best one is the Ncache. This is the one that I was kind of mentioning. This is what we're gonna install for now. It's just gonna, like, it's a Windows service running. It's gonna basically be Ncache Windows service that's managing the cache. That you can, whenever I'm busting the cache, I don't have to, I'm gonna interface. That console application that you wanted to for me to write that's going to invalidate the cache. It's going to basically interface directly with this guy to kill all the cache, and it's going to rehydrate it. So.
And then real quick, I see Jim's not on the call, but what's the best way to test this particular NuGet as we're making changes to it? Is this going to be all through unit tests, or is there going to be another way to kind of test this?
Well, I have instrumentation, common instrumentation, and I have performance counters added here. So, we can have a perfmon running and create some web tests, right? And then you can see, the cache hit miss rate. Really, this is part of the core framework that needs to be tested, tested via, unit tests and integration tests. And then we can have some performance tests that are basically, hitting our API endpoint and, simulating 30 concurrent clients or 60 concurrent clients. And then you can enable performance monitoring, and then you can see he can say, oh, well, we had 60 concurrent clients that requested the API 200 times, and we have 100 misses. you know, there's something wrong with that, right? It shouldn't be like that. It should be maybe, you know, 10% misses, you know, thinking about the code. So it's not as easy to test, but you can still, you know, we're gonna, I'm going to add, again, these are unit tests and integration tests, but I'm gonna add performance testing, like these guys. You know, web performance and load test. That's the one that I'm going to, you know, load test the API endpoints, and then, I mean, this code UI can really replace our Selenium, but you know, that's a different story. Yeah, so that's how. And again, the build cycle for these. Once we start building our, and this is kind of for everybody. You know, I'm going to be establishing some guidelines with this code bases that I'll be checking in with, you know, our unit test, performance test, mocking, you know, for example, I really like to use MOQ. I know there's different, a lot of different mocks out there, but, you know, I mock with, you know, MOQ, and so, you know, I kind of encourage everybody to follow the same standard. This is for unit testing. We can actually mock out the, you know, your interface, and then, you know, set it up. So the life cycle of the core libraries, this is going to be part of core, which is going to be, it's going to go inside of these feeds, right? So, you know, I created these swim lanes for these different feeds. So you have common, this is part of the core framework, like cross-cutting concerns, logging, stuff like that. Then I have data access, that's going to be our repositories. Common is going to be going in here. Then basically our, you know, service layers, service gateways, business components, you know, presentation for the API and stuff like that. These can be all separate NuGet packages. So for example, if I'm creating a presentation layer, like I'm creating a console application or a website, I don't want to see a huge solution like this, you know, that has bunch of local, and then you're referring it locally. I just want to, you know, have this website code and then bring in the NuGet packages that I need from our NuGet server. So I'm going to bring in the common, the caching, bring in whatever, you know, just like we do for others. And then NuGet feed support NPM as well. So we can package our JavaScript, our script code as well. We can break it out and package it into NuGet packages that can be built continuously. It can be versioned continuously. It can be attached to our build. This is a lot of changes from the way it's working now, but this is going to give us, in the long run, it's going to give us, you can look at the release note. This is really mostly for Jim. Jim will be able to look at the release note for the release branch that he cut. And he can know from the release notes, first of all, he will have the release notes. Second of all, he will know what is deployed where and which solutions are part of which, you know, which branch and which builds, and, you know, all that stuff, and how long stuff has been built. Now, maybe I should stop recording because this is not part of this